In the last video, we looked at the Pythagorean Theorem. I reminded you that if you have a right triangle, then the sum of the squares of the two legs is equal to the square of the hypotenuse. Now we're going to look at it the other way around. We're going to see what is the relationship of a square of the largest side in comparison to the sum of the squares of the other two sides. So in a case, if we know we have a right triangle, of course the Pythagorean theorem should still work. We should still have that c squared is equal to a squared plus b squared. Now it's important that we start with c squared because if you switch it around, it gets really confusing later on, so make sure throughout this entire practice, throughout the entire homework, using the Converse of the Pythagorean Theorem, you start with c squared every single time. If you start to not start with c squared, it's going to get very confusing later on. And I'll talk more about that later. So here we have a triangle. Notice that I have started with the largest side square. And I am looking to see if the square of the largest side is equal to, greater than, or less than the third side. So we have that 25 is 5 squared, and we have 9 plus 16 is the squares of 3 and 4, and so we have 25 in relationship to 25. What's true about that? How do you make this statement true? Put an equal sign. 25 is equal to 25, and so this is a right triangle. Now, we've seen that when a triangle satisfies the Pythagorean theorem, it's a right triangle. But as I mentioned before, it could be less than or equal to as well. The square of the largest side less than or equal to. So let's see how this happens. Remember, we want to start with 5 squared, the largest side, square it, and compare it to the sum of the other two sides. So here, one thing I want to mention, these numbers, these two sets of 3 numbers means measures of triangles. So we're looking at measures of sides of 2 triangles, and we're comparing them against the Pythagorean theorem. So here we have 25, we have 4 plus 16, so we have 25 compared to 20. What sign would make this statement true? A less than sign. A greater than sign. A greater than sign would make this statement true. This means that c squared is greater than a squared plus b squared, which makes this triangle obtuse. Let's look at the other example. We have 9 squared, square of the largest side, compared to the sum of the squares of the 2 smaller sides. 81 compared to 25 plus 36. 81 compared to 64. Again, we have that the square, c squared, is greater than a squared plus b squared. And so again, we have an obtuse triangle. Now in all the other examples of triangles, I have actually chosen three numbers that could work as measures of a triangle. Like you could actually physically draw the triangle. In this case, I'm going to show you what happens if we don't have a triangle. How do you know if three measures make a triangle? Well, let's look at the example of the Pythagorean Theorem right triangle sides that we looked at the beginning of the video. 3, 4, and 5. We know this makes a triangle. We saw it make a triangle before. It has to make a right triangle. So how do we know mathematically? How can we prove mathematically that this is a triangle? If we take the sum of two sides, any two sides, and compare it with the third side, we should get that the sum of any two measures of two sides should be greater, that means greater, than the measure of the third side. So let's look back down here at the example in purple down at the bottom of the right hand side of the video. 3 plus 4, what is that in relationship to 5? Well, that's 7, and so that's going to be greater than 5. So yes, those two sides are greater than the third side. 4 plus 5, that's 9. That's definitely greater than 3. And 3 plus 5, that's 8. That's greater than 4. And so in this case, we have a triangle because in 3 cases, when we took any two sides of the triangle, added those two sides up, and compared it to the third side, we got that the sum of the other two sides was greater than the third side. Let's look at this other example. 2, 3, 5. Well, in this example, if we get 2 plus 3, what is that in relationship to 5? That's equal. That's not greater, and so therefore we do not have a triangle. Let's look at a few other examples. Okay, 6 plus 4. Yep, that's greater than 2. But 6 plus 2, that's greater than 4. But 4 plus 2 is equal to 6, and so we don't have a triangle. Here I'll let you know that radical 3 is approximately 1.7, and so we have radical 3 plus 1. Yep, that's greater than 2. We have 2 plus 1. Greater than radical 3? Of course. And 2 plus radical 3, definitely greater than 1, so we have a triangle. 7 radical 3, well, that's approximately 12.3. Plus 7, greater than 8? Of course. 7 plus 8, greater than 7 radical 3? Well, I just told you before that 7 radical 3 is about 12.3, so that's true. And 8 plus 7 radical 3, 8 plus 12.3 is definitely greater than 7. And so we have a triangle here. Now you try. Why don't you pause the video, and before we go on to the next slide, the summary slide, you can try a few of them. In summary, if you have a right triangle, then the sum of the greatest side is equal to the sum of the other two sides. If you have an obtuse triangle, then the greater side square is going to be greater than the sum of the other two squares of the sides. And if you have an acute triangle, then the square of the largest side is going to be less than the sum of the squares of the other two sides. And how do we make a triangle? If you have a triangle, if you pick any two sides and add them together, they must be greater than the third side.